Hello everybody. So in this video we are going to talk about orthocenter and incenter. Let's start with it. So if you have got a triangle over here, any random triangle, suppose PQR, and if you take an altitude of it, this is an altitude, right? Suppose this is A. So PA over here is an altitude. In general terms, you call it height as well, altitude. Right? In the same manner, you can make another altitude like this. Suppose this is QB, and then you take another altitude like this, suppose RC. So this is QB and RC. These are altitudes of this triangle, right? The point of intersection of the three altitudes of a triangle is called its orthocenter. This point is the orthocenter. Again, I am saying the point of intersection of the three altitudes of a triangle is called its orthocenter. Right. Now over here you see this is an acute angled triangle. So orthocenter is inside the triangle. Now suppose I take an obtuse angled triangle like this. Suppose PQR. An obtuse angled triangle. So you see from this, if I take the altitude, and you see from this, how will I take the altitude? I have to extend it backwards. So this is the altitude, right? Then from R, how will I take the altitude? I have to extend it backwards. So this is the altitude. Now you see if I extend these altitudes over here. So I hope you understand this is a rough figure, guys. This is not, it will be like this. I hope you understand. Maybe I'll just, see, if you extend it backwards, it will be somewhat like this. That's not exact. I hope you understand that. It's rough figure. So you see, this is the altitude. So in an obtuse angled triangle, the orthocenter will lie outside the triangle. In an acute angled triangle, the orthocenter will lie inside the triangle, the point of intersection of the three altitudes of a triangle. Right? Now you see, if I ask you a question that if we have been given with some points, suppose P0, 3, O0, 0, and Q4, 0. If suppose these are the points over here, and if you join these points and you make a triangle out of them, the question is, what will be the coordinates of the orthocenter of this triangle? So for that thing, you have to understand one thing. For example, if you have got a right angled triangle, suppose this is PQR, you see from this, if I want to draw altitude on QR, so PQ is the altitude. And from R, if you want to draw altitude on PQ, then RQ is the altitude because this is 90 itself. You see this. And from this, if you draw the altitude, it will be like this. So the point of intersection of the altitudes is this one only. So in a right angle triangle, the vertex containing the right angle is the orthocenter because that is the point of intersection of the three altitudes. So in a right angle triangle, the vertex containing the right angle is the orthocenter itself. So over here, if I draw in rough, if I plot these points in rough over here, this is P0, 3, and then this is the origin 0, 0, and then this is 4, 0. If you join these points over here, you see this is the orthocenter. This point is the orthocenter because this is a right angle triangle and the vertex containing the right angle is the orthocenter. So therefore, these are the coordinates of the orthocenter of this triangle. I hope that's clear. It's a basic question. Now sometimes they give you a question like this. For example, you have got a triangle, suppose PQR, correct? And suppose O is the orthocenter of that triangle. O is the orthocenter, correct? And suppose angle P is given to us, suppose 50 degrees. And then they are telling you to find the value of the angle QOR. I hope you understand that. Right? So you can make a rough figure over here. Any random triangle. Suppose this is PQR. Correct? Now, how will you show the orthocenter? You see, you take the altitude from this and you take the altitude from this. Even if you take two altitudes, then also this is the orthocenter. Then also this is the orthocenter, right? Even if you don't take the third altitude, then also this is the orthocenter. Now, over here, just understand one thing. Suppose this is PQR, this is S and this is T. So if you take quadrilateral PSOT, in this quadrilateral PSOT, you see this is 90 and this is also 90. Now you know that sum of all the angles of a quadrilateral is 360 degrees, correct? So over here, can we not say that angle P plus angle SOT, P plus SOT is equal to 180? Because sum of the other two angles of that quadrilateral is also 180. You see, this plus this is 180, so this plus this will also be 180. Correct? And you see SOT is equal to QOR, vertically opposite angles over here. So if you find angle SOT over here, what is that, guys? That is 180 minus angle P. Or you can say over here that angle QOR is equal to 180 minus angle P. This is an important result which you can remember, that if there is a triangle PQR and O is the orthocenter, then angle QOR will be 180 minus the third angle. The third angle is 50 in this question. So that is 180 minus 50 degrees. So 130 degrees is the answer. I hope that is clear, guys. Okay. Let's move forward. Now we will talk about the in-center of a triangle and we'll try to derive the formula to find the in-center in the case of coordinate geometry, when the coordinates of the three vertices of a triangle is given to us. So, if you take a triangle over here, any random triangle, right? Suppose this is PQR. And you take the angle bisector. Angle bisector means this angle is equal to this angle. And you take another angle bisector. This angle is equal to this angle. And you take another angle bisector. This angle is equal to this angle. So this is the in-center. The point of intersection of the three angle bisectors of a triangle is called the in-center. The point of intersection of the three angle bisectors of a triangle is called the in-center. Now, in-center is the center of the in-circle. In-circle is a circle which will touch the triangle from inside. So that is the in-circle. And the radius of it will be obviously in radius. Correct? So finding in radius is also, there is a formula in that as well. I'm not talking about that thing in this video. I'll make a separate video for that. That's a simple thing, right? You must already be studying that even in CBSE grade 10. Maybe by that name it's not there in circles chapter, but finding in center is there in the syllabus. In radius is there in the syllabus. So again I will repeat, the point of intersection of the internal angle bisectors of a triangle is called its in-center. Now whatever might be the type of the triangle, whether it's an acute angle triangle, whether it's an obtuse angle triangle or a right angle triangle, the in-center will be every time inside the triangle. Why? Because the angle bisectors of the internal angles will be inside the triangle every time. Whether you take, you see, if you take an obtuse angle triangle, the bisector of the angles will be like this. So this will be the in-center. Same will happen in a right angled triangle as well. Now let's derive the formula to find the in-center of a triangle when the coordinates of the three vertices are given to us. So for example, see this thing. If there is a triangle like this, in which suppose this is P x1 y1, Q x2 y2 and R x3 y3. Suppose it's like this. And suppose the side opposite to P is A, length of the side. Length of the side opposite to Q is B and length of the side opposite to R is C. We want to find the coordinates of the in-center of this triangle. So you see, if I take this angle bisector over here, it means this angle is equal to this angle. And I take the angle bisector over here, this is equal to this, right? Even if I don't extend it and even if I don't make the third angle bisector, still I can say this is the in-center, guys. That's easy to understand. Still that is the in-center. Very basic. I hope you understand that logic. Suppose the coordinates over here are x comma y and we have to find these coordinates. In terms of what? In terms of x1, y1, x2, y2, x3, y3 and a, b, c. The coordinates of the three vertices and the lengths of the sides. We have to do that over here, right? So you see over here, this is P, Q, R. Suppose this point is S, okay? Now you see this is the bisector over here. Can we use the angle bisector theorem? C upon B is equal to QS upon SR, right? QS upon SR, that is equal to what, guys? C upon B. Internal angle bisector theorem, I guess obviously you have studied that. So you see QS upon SR is C upon B. I hope that's clear. So you see over here, this is C by B, C upon B. Maybe over here I will write C upon B. So can we find the coordinates of point S over here? It will be Cx3 plus Bx2. So Bx2 plus Cx3 upon B plus C, section formula, and then Cy3 plus By2 upon B plus C. So you can write By2 plus Cy3 upon B plus C over here. Correct? Now you see over here, this is C upon B and this total is A. So can I not say that QS will be what? It is C upon B plus C part of what? C upon B plus C part of A, because A is total over here. I hope that is clear. Now you see, in order to find this thing, I need Pi upon Is. Understand that logic patiently. Pi upon Is. Because again I have to use section formula. You see over here, this is the angle bisector. So Pi upon Is. Pi upon Is will be what? C upon Qs. It will be C upon Qs. Angle bisector theorem. So C upon Qs, we have got this thing. C upon B plus C into A. So this will be cancelled out. B plus C will go in the numerator. So that is equal to B plus C upon A. I hope this logic is clear. So you see, Pi upon Is is B plus C upon A. Now can we use section formula to find x over here? So you see this ratio, this upon this, we understand, it is this. So it will be what? B plus C, maybe I will write over here. Pi upon Is, we have got B plus C is to A. So this is B plus C part and this is A part. Now that does not necessarily mean that Pi is equal to B plus C and Is is equal to A. The ratio of Pi is to Is is B plus C is to A. I hope that logic is clear, right? So x will be what? If you use section formula, it will be this into this x coordinate, then this into this x coordinate. So that will be B plus C into, see that very patiently, B plus C into x coordinate of this point, which is what? Bx2 plus Cx3 upon B plus C. And then what you will have? A into x1. You'll get A into x1. The whole divided by what? it will be this plus this, which is nothing but A plus B plus C. So what you can see, you can cancel it out. So you can say this is AX1, BX2, CX3. Is that clear? AX1, BX2, CX3 upon A plus B plus C. I hope you got it. In the same manner, y coordinate of the in center over here will be what? Same logic, AY1 plus BY2 plus CY3 upon A plus B plus C. Same pattern, same logic. So you see the pattern is very simple. How will you find the coordinates of the in center? It will be x1 into length of the opposite side plus x2 into length of the opposite side, x3 into length of the opposite side. You see ax1, bx2, cx3 upon sum of the lengths of sides. Similarly, it will be y1 into length of the opposite side plus y2 into length of the opposite side plus y3 into length of the opposite side. So ay1, by2, cy3 upon sum of the lengths of the sides. So that's the formula to find the coordinates of the in center of a triangle when the coordinates of the three vertices are given, right? So let's do a simple question on the basis of this concept. Suppose they are telling you that the coordinates are given of the vertices. Suppose I'll try to take simple values over here. Suppose the coordinates of the three vertices of a triangle is given like this. They are telling you to find the coordinates of the in center of that triangle. So what will you do? First thing is, in rough you can plot these points. So you see this is the origin 0, 0. And P0, 3 will be on the y-axis because its x coordinate is 0, and Q4, 0 will be on the x-axis because its y coordinate is 0. If you join them, you will get a right angle triangle, guys, where this is of 3 units, this is of 4 units. You can easily use Pythagoras theorem over here. It will be 5 units. You know, you have studied this since childhood. The most famous Pythagorean triplet, 3, 4, 5. Correct? So the coordinates of the in center will be what? Suppose x coordinate I am saying. See, x coordinate into length of the opposite side. So that will be 0 into 5 plus x coordinate into length of the opposite side plus x coordinate into length of the opposite side, 0 into 4, divided by sum of the lengths of sides of the triangle. So 3, 4, 5. So you see this is 0, this is 0, this is 4 3s are 12, and this is also 12. 12 by 12 is 1. You can check it once again. X coordinate into length of the opposite side, that is 0. X coordinate into length of the opposite side, that is 12. And then x coordinate into length of the opposite side, 0. And sum of the lengths of the sides is also 12, so that will be 1 only. In the same manner, y coordinate will be what, guys? Y coordinate into length of the opposite side plus y coordinate into length of the opposite side plus y coordinate into length of the opposite side divided by sum of the lengths of sides, 3 plus 4 plus 5. Now you see this is 0, this is 0, this is 12 upon 12, that is 1. So what we can say? The coordinates of the in center of this triangle is 1, 1. The coordinates of the in center of this triangle is 1, 1, and that's a direct question on the basis of the formula to find the in center, coordinates of the in center of a triangle. Now one more type of question is asked many a times, and that's also basic. You see over here. For example, they are telling that you have got a triangle PQR. Okay. Suppose I is the in center of that triangle. Suppose I is what? The in center of that triangle, right? Suppose angle P is given, suppose 40 degrees. And you have to find angle QIR. That's a question. And that's important. It's very simple, but it's important. So basically what they are saying that you have been given with a triangle like this, suppose PQR, where I is the in-center, like this. So even if you take bisector of angle Q and bisector of angle R, and if you don't take the third bisector, then also this will be the in-center. Now in class 9, if you are a CBSE student and in other boards as well, you know that the angle between the two internal angles of a triangle, two internal angle bisectors of a triangle, angle QIR, that will be 90 plus half of third angle. 90 plus half of third angle. This has been proved many times on this channel as well. So this is 90 plus, the third angle is 40 over here. So that is what, guys? This is 20. So 90 plus 20 is 110. So 110 is the answer. But you have to remember this relation. You have to understand what is an in-center, and you have to remember, you must be able to recall this relation as well. I hope this is clear. And that's all I needed to discuss over here, guys, on the basis of the concept of orthocenter and in-center of a triangle. Obviously, some formulae is with respect to trigonometry as well. In this video, I'm not discussing that. I'll make a separate video for that. That's all we needed to discuss. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is being discussed in live sessions, you can get the PDF of those sessions as well. Bye-bye guys. Take care everybody.